All right. Okay, good. Well, it might be a recording. Let's check it out. Okay, number one. First of all, again, what we're going to do is just move negatives. Okay. Y to the 1 comes up. X to 0 becomes 1. Y to the negative 4 to the negative 3 comes down to 4 to the 3. Okay, so I just moved the negative exponents. Okay. When I move them, they become positive. That's the whole reason we move them. And then anything 0 powers 1. So I'm going to finish this up. I'm going to have an answer of y over 4 times 4 is 16 times 4 is 64. Okay. So the 1, I could put the 1 in there for a 1y. I don't need it, but I can put a 1y. You okay with that? Like 1y and y are the same thing. Annie, can you see?
Not really.
You want to sit here for right today? Okay. All right. Number 2. Okay, so thumbs up on number 1.
Yeah.
So if it's a negative exponent, just move it. Yeah, come on up, Annie. That'll help, okay? Number 2. Okay, again, I know it's got to be, there's 2 ways to do it, and I'm going to do it the slow way, which is okay. If it's a negative exponent, move it down, right? So I'll have a 2 to the 4th, and I'll have a 2 to the 3rd. Is that better? Good. Okay. So now I've got on the top 2 times 2 times 2, and on the bottom I've got a 2 times 2 times 2 times 2, right? So in a sense, 3 of these will cancel 3 of these, right? Mm-hmm. So if that happens, there's only 1, 2 on the bottom, and there has to be a 1 on top. And the reason there has to be a 1 on top is if we do this the long way, 2 times 2 times 2 over 2 times 2 times 2 times 2. 2 divided by 2 is 1, right? 2 divided by 2 is 1. 2 divided by 2 is 1, and that's why we have the 1 on top, and all we're left with is just a 2. Okay, that's not so bad, is it? Thumbs up? Questions by anybody?
Wait, hold up.
I will.
So why is there 1 on the top?
Okay, great. One more time. So if I write this the long way, Landon, 2 to the 3rd is the same as 2 times 2 times 2.
Yes.
And then 2 to the 4th is the same as 2 times 2 times 2 times 2, right? What is 2 divided by 2?
1.
There's where the 1 comes from.
I know, but then there's still 1, 2 on the bottom.
Right. So then, if you have a 1 times that 2, it's just 2, isn't it? Okay? All right. Or, Lana, what's easier is cancel, cancel, cancel. What's left over? Just a 2, right?
Yeah, but it's on the bottom.
Right. It is on the bottom because there's more of them on the bottom than on the top. Right? So all of that...
Yeah, no, okay.
Okay, number 3. So I'm going to do this. I'm going to do this where it's going to be 1 to the negative 5. This is probably one of the harder ones. 1 to the negative 5, okay? 2 to the negative 5. A to the negative 15. Okay, so what I did is I brought the negative exponent in. 1 to the negative 5, 2 to the negative 5, and a to the negative 15 because I multiplied exponents, okay? Now, let's see what I can do with this. Well, 1 to any power is always 1. 1 to any power, doesn't matter. 1 to any power, I don't care what it is, 1 to any power is always 1. Always.
That's right.
Okay, and then this 2 to the negative 5 comes up as 2 to the positive 5, right? A to the negative 15 comes up as a to the 15, okay? How am I doing?
Doing great.
Now, I could leave a 1 on the bottom. Yeah.
Oh,
Okay. I could bring the 1 down, but 1 to any power is just... Right, you with me, Josiah? I could bring this 1 to the positive 5 down here. I could. But 1 to any power is always just 1, right? Okay, so let's finish this up. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 2. So I'm going to have a 32, a 15 over 1. I don't really need the 1. If you want to put the 1 there, you can.
wait, so that's the answer. So
That's
we-
it.
we did
Yeah. Okay. All right, number 4. Am I going too fast? Am I okay? Okay, I'll wait for you. I'll wait for you.
Wait.
You got it?
Yeah.
Okay. So number 4. That is a cube root, and that is a square. So I'll rewrite this as the cube root of negative 27 squared. Okay? Cube root, because of the little 3, that's my root, and that's my power. So I wrote it as cube root of negative 27 squared. Okay? So far, so good? So, let's do the cube root first. What times what makes negative 27? Negative 3. Negative 3. Let's go through it. Negative 3 times negative 3 is positive 9. Times the negative 3 is at negative 27. So we know the cube root of negative 27 is equal to a negative 3. And then negative 3 squared is a positive 9.
I'm so confused.
Sure, let me do it again. Let me do it again. So cube root of negative 27, right, is negative 3. Then I still have to square it. Negative 3 squared is positive 9.
Is this, can we do that on a calculator?
Yes, you can do that on a calculator, which if you want to, go ahead. I'm just going to keep moving on. Yes. But you can't do number 5 on your calculator, right?
Yeah.
Now 5 actually should be one of the easier ones. Super easy. It's just going to be 12 y to the 6th over x to the 7th. That's all you do.
That's it?
That's it. That's it. What did I do? I just moved this. I just moved the x to the 7th down, didn't I? Right, that's all I did. Okay. 6. Okay, you ready for 6?
I'm ready for 6.
I'm going to have a negative 4 to the 3rd power and an x to the negative 6th power. Okay, I brought the cube into the problem. I brought it in. There and there. Okay. Now, negative 4 times negative 4 is a positive 16 times another negative 4 is a negative 64. Okay, I'll do it again. Negative 4 times negative 4 is a positive 16 times another negative 4 is a negative 64. So I have a negative 64 over an x to the positive 6 because I brought the x down because it had a negative exponent. That's it. Yeah. Okay. Now, on 7, 8, 9, excuse me, on 7 and 8, I just have to have 3 things. As I do it, I'll show you the 3 things I need, okay? I need to know where it starts, and I need to know the shape, right? Okay, so in 7, I'm going to go ahead and draw my axes in. 7. And I'm going to start at negative 5. 1, 2, 3, 4, 5. Okay, got to do that. Now, these are those J-shaped graphs, right? They're exponential. This is an exponential graph, so it's going to have that shape, except for this one's upside down because of the negative, okay? So it's got to be upside down. It's going to grow, but it's going to grow in a negative way, okay? Does that make sense? It's kind of like the national debt. It grows exponentially in a negative way. So all we need is this kind of graph like this. Right? See it? That's it.
Like rough graphing?
Yeah, rough graph it. But I do need shape.
Go down 5.
I need shape. Go down 5. And don't let it touch the x-axis, right? I'm going to put in the asymptote. Remember that thing called the asymptote? I'm going to draw in the asymptote. So if I draw in the asymptote, it's right there. But remember, it never touches that line, okay? So if you can give me 3 things, correct shape, the starting point, and don't let it cross the x-axis, you're going to get it correctly, okay? That's all I need. So what is the domain and range of this? So what's the domain? How wide is this graph?
Infinite.
Yeah, x equals all real numbers. Yep. And what about the range?
Less than 0.
Less than 0. Who said that? Yes. Nice job, Caleb. It doesn't equal it, but it's less than 0 because it never touches 0. So no equal sign. No equal sign because it never touches 0, does it? Just less than 0. Nice job. Okay. You guys ready for number 8?
No.
Okay, I will wait. That's why I asked. Hannah, give me thumbs up when you're ready. Okay, anybody else ready? Okay, let's take a look at number 8. Okay, so number 8, I'm going to start way up at 48. So I'm going to start way up at 48, so probably go, I don't know, I'm going to go 10, 20, 30, 40, 50. So I'll estimate, 48's about, it's about there, right? I know it's decay because the 0.5, right? So it's going to have it's going to go down. So the shape should look something like this. You ready for that? I'm going to put in the horizontal asymptote because I like to. And the horizontal asymptote helps me with the range. Okay, so what's the domain? Yeah. X equals all real numbers. And what's the range? Just greater than 0. Yes, y is greater than 0 because it never touches 0. It can never equal 0. That's like that half of a half of a half of a half of a half. You'll never get to 0, right? In theory. Okay, whisk this away. No, I'll wait till you're ready. Okay. Okay, here we go. So number 9, absolute value graph. I can do that. That's pretty easy. Hopefully it's pretty easy for you guys by now. And the vertex of this one is at +2, +5. Okay, vertex at positive, opposite of the inside, right? Opposite of that. So let's go to 2, 1, 2, 3, 4, 5. It has a positive slope. It has a positive slope. It's going to go up. But the slope's up 2 over 3. Whoop, I think I missed one. Up 2 over 3. 3, 2. So my graph looks like that. So most of this quiz you already know, or this test you already know, right? Most of you do, because we've done a lot of this already in our first quiz. So what's our domain? Yeah, x equals all real numbers. And what's our range? Yes, greater than or equal to 5, because you start at a height of 5, right? And you go up. Okay, and I'll wait till you're ready. I'll wait, and then we'll do the piecewise, okay? Is this helpful?
Yes.
Good. Thank you for being quiet. It helps everybody learn. Even if you're like a smarty pants, thanks for just being quiet so the rest of us can learn. Okay? All right? You good? Okay. All right. Number 8. All right? So we're going to do a piecewise graph. And the first thing I like to do is put in my border points. So I'll do a border point at 4, at 2, so my border lines, right, and at -2, okay? Okay. And I like to use a highlighter. You don't have to. I just like highlighter because then I know for sure it's not part of the graph. It's an invisible line, right? Okay. Now, y equals 2. That's straight across 2. But 2 is in between 2 and 4. It's going to be in this first area here. So this one's written a little backwards, isn't it? But the 2 is in here. So I'm going to go ahead and put it. It goes all the way across the 2, but it's going to be right here. Solid dot at 4. Open circle at 2. Okay? That's its piece, okay? Second graph, we start at 0. I'm going to go up 3, 1, 2, 3, over 2, 3, 2, and this graph is only in here. Now these two don't touch, but they don't have to, right? Solid dot, open dot. And finally, -4, y equals -4 is straight across -4, but that's from x is less than -2, so it's going to be like this, and another open circle, which is okay that you have another open circle, okay? As long as you don't have 2 dots in the same spot, right? Now, there's 2 ways to find f of 0. One is just look at the graph. I mean, at 0, what's the height?
0.
There you go. That's the answer. That's the answer. The answer is just 0, okay? Or we could plug 0 into right there. Plug 0 into here. You get 3/2 times 0, and you get 0, right? It's easier to get it off the graph, though. You guys agree?
Yeah.
Yeah. Okay. Almost there. Number 9. And I might need another piece. Oh, I can do it right here. So first of all, find the inverse. Graph it. Okay, so number 9.
Wait, you have 2 8s?
Yeah, and 2 9s.
Oh my goodness. I know why, but you know I should probably fix that. Yeah. Because I try and make the test first, and then I make the review sheet, and then I take some questions off and add some things back. So that at least you know it's like the test, don't you?
Yeah.
Right? Except for I probably should have gone back and fixed the numbers, huh? So it is, Zoe, just like the test.
Okay.
I mean, you know, because I got 2 8s and 2 9s. So I forgot to change the numbers. All right, I will change that later, though. So here we go. So number 9, let's start at. So the original function, let's start at 1, right? Down 1 over 3, down 1 over 3. Okay. Here's f of x. Now the inverse, there's 2 ways to the inverse, and it doesn't matter to me how you do it. Doing it point by point is not a bad way to do it. Let me see if I got a different color. Oh yeah, I got blue. So if you do the inverse, one way to honestly do it that always works is just reverse the points. Okay, this is the point at 0, 1. So its inverse would be, instead of 0, 1, it'd be at 1, 0. Right? This point is at the point 3, 0. Its inverse would be at 0, 3. This point's at 1, 2, 3, negative 3, 2. Negative 3, 2. So it'd be at 2, negative 3. Okay, so I pretty much have the graph, right? Now, if you can graph it, then you could get the equation of the inverse just from your graph. You agree with that? So an easy way, and I'll do both, an easy way to say, hey, I know what the equation of this is. It's easy. It's just simply going to be f inverse is equal to, let's see, it's going to be negative 3x plus 3. Yeah, and that I got that from just looking at the blue line, right? Or we can just do the math, okay? So I graphed the line by reversing all the points. I reversed all the points and got the blue line. Looked at the blue line, so what's the equation of the blue line? It's down 3 over 1 plus 3, okay? That's the inverse. Negative 3x plus 3. Now, however, we could do it the other way, right? And we can go and switch variables and make it x equals a negative 1/3 y plus 1. This is the other way to do it, right? So you just switch the variables. Minus 1, I'm going to have an x minus 1 equals negative 1/3 x. Multiply everything by a negative 3, and I would get an answer of f inverse is equal to a negative 3x plus 3. Okay, that's the other way to do it. Both work. Okay, both work. All right, last one, huh?
Wait.
Yep, I'll wait for you.
You don't trust me at all?
So can we not have homework?
Equation.
Yeah, you have homework tonight. Because you need to keep practicing, right?
I thought 3.
Okay, now, number 10. Let's do number 10. We'll almost be done, okay? So, first of all, I'll do 10 on this piece of paper. So it's exponential, okay? I'm going to start right off with a. We're going to write simply y equals a times 1 minus r to the t. I'm going to use that equation. I'm going to use that equation because it's depreciation.
Yeah, it is.
And it's percentage, okay? So I'm going to go minus r, okay? And r is the rate. So write that equation down. Make sure you have that equation. So then we're going to go, all right, y equals 12,599 times 1 minus 0.08 to the t power, okay? And you could change that if you want to. This answer is fine. I'll take this answer. Of course I will. It's correct. Or you could simplify it to y equals 12,599 times a 0.92 to the t power. Okay, either equation's fine. These are the same. I just went 1 minus 0.08. That's all I did. So what is 1 minus 0.08? 0.92. So there's the equation. Everybody can do that. And I'll take either answer. They both work. Okay, now, what's the value after 2.5 years? Well, I need a calculator. We're going to plug it in, right? Let's see if there's a calculator on my desk. Maybe. So let's check it out. Let's see what we got. Okay? Just use our calculator and figure it out that way. So I'm going to go y equals 12,599 times 0.92 to the 2.5 power, right? Just use my calculator. Just going to go clear 12,599 times 0.92 to the power of 2.5, right? So I got $10,228.35, okay? $10,228.35. Okay, you want to see the calculator? Okay, there's the calculator, okay? Okay.
228.
Okay, now, when will the car worth $3,000? We're going to have to graph it to do that, right? So I'm going to go to my graph on my calculator, y equals, and I'm going to type it in. I'm going to go, okay, my 12,599, oh, too many nines, parentheses, 0.92 to the power of x. Now, I got to think about my window. I got to be smart. Okay, I've got to type in, think about my window. How long is my car going to last? Well, if it's me, I drive my car until they fall apart. Right, Landon? Yeah, I drive them into the ground. It's like, doesn't matter how ugly they are, I just keep driving because they're paid for, right? So me, I'm thinking my car might last me, if I'm lucky, 30 years. Man, that'd be pretty awesome. Wouldn't 30 years be awesome?
Wait, so
So I went to my window, and I'm saying I'm going to go from 0 to 30 because I'm hoping my car's going to last for 30 years because that means I'm not paying the bank $400 a month, right? That $400 going into my pocket, not in the bank. Okay. So then, the value, I do know that 0 to, and I'm looking for at least, I'll go 12,600 because that's the value of the car when it's new, right? So if I start there, and it's just going to go down, right? Okay. So now I'm almost ready to graph it, but I'll wait till you guys get caught up to graph it, okay? So I should see a depreciation, and then I'm going to use my trace button to find out when it's worth 3,000. Okay, so you ready? Graph. Okay, there it is. It's depreciating. It's got the same kind of curve that we're looking for. I'm going to go to my trace button. Okay, so I go to trace, and I'm looking for the y value when it's 3,000. I'm pretty close, aren't I? So I'm looking for y value when it's 3,000. It's right about 17 years, right? Pretty close to 17. So I'm going to say about 17 years. Okay. All right, how's that? So don't lose this.